Good day, students. Welcome to a clip on how to solve systems of equations using augmented matrices. So I'm going to go over two examples for you, and this is basically a trick on how to really solve systems really quickly using your graphing calculator. All right, this process works for TI 84, 83, or even the 80, 90, 89. Okay, so question number one. Let's say you're given the problem, solve the given system, solve the given system. Let's say we're dealing with a two variable system. First of all, let's say you had negative 2x plus 3y equals 8 and 3x minus y equals negative 5. Okay? So let's say you have the system of equations that you asked to solve. So I'm going to show you how to do this using a calculator. So the first thing you have to do is you have to translate this into an augmented matrix. Okay? So to translate this into an augmented matrix, all you simply need to do is extract the coefficients from your system. Okay? So you're going to extract negative 2, 3, and 8. That will create your first row on your augmented matrix. And then you extract 3. There is no number here, so what I'm going to do is I'm going to put 1, all right? If you don't have a number, just put 1, because that's a multiplicative identity. We're going to extract negative 1, and then 5, and that will be my second row in my augmented matrix, okay? So let me show you what the matrix is going to look like. So in augmented matrix form, in my first row, I'm going to have negative 2, positive 3, and 8. And then in my second row, I'm going to have 3, negative 1, and negative 5. All right? So we have a 2 by 3 matrix. All right? So I'll draw a line right here. When I put this matrix in reduced row echelon form, the numbers here are going to be my solution. Okay? So what we're going to do, we're going to try and make this become the identity matrix. Okay, if this becomes the identity matrix, then whatever you have here is going to be your solution. All right. If you don't know all the lingo I'm using right now, it's fine. I'll just show you the procedure, and you see how cool it is to find the answer. All right. So what I'm going to do is I'm going to use a special function in my calculator called the reduce. Oh boy, I'm going to use a special function called RREF. RREF. Okay? I'm going to name this matrix, I'm going to name it matrix A in my calculator, okay? And what I'm going to do is I'm going to carry out the RREF of matrix A. Okay? RREF is just a condensed form of saying reduced row echelon form. Okay? Reduced row echelon form. Okay? Echelon form. You don't need to know what it means, but that's what the REF means. Okay, so I'm going to do REF on this, and I'll show you what the answer looks like. Okay, so now I'm going to enter this matrix into my calculator. There are two different ways of doing it. I'm going to use a faster method of doing it. Okay. Now I have done a tutorial on how to enter matrices in your calculator. If you want to view it, you can just click down here, and you go over that tutorial. All right, so let me go ahead and enter it. So I'm going to enter them row by row. So to open the entire matrix, I'm going to use the bracket here above x, and then to close the matrix, I'm going to use a negative right here. Okay, so to open the entire matrix, I'm going to go second function times. Second function times opens the whole matrix. Okay, now I'm going to enter the first row of the matrix. All right, so to open the first row, I'm going to use another bracket to open the first row. I'm going to enter the elements and delimit or separate them with a comma. All right, so I'll use negative 2. Don't use this minus right here because that's an operation. Okay, this is the sign that you use, negative 2, separated by a comma, 3, comma, 8. And then I'll use second function minus. You see this yellow option here? That is to close out the first row. Okay? Now I have the first row entered. Now I have to enter the second row into the calculator. So I need to open the second row with another open bracket, and then I'm going to enter 3 separated by comma, -1, another comma, and then -5, and then I'm going to close the second row. I just closed the second row. Now I need to close the entire matrix. Entire matrix closed. Now I'm going to store this in a matrix of a certain assignment. So I'm going to press store. Now if you want to access the matrix list, you see this matrix right here? Guess what it means? Matrix. Alright, so I guess you guessed correctly. To access it, since it's yellow, I'm going to use the second function. Alright, so second function, x to the -1, takes me to the matrix list. And I'm going to pick, let's say, matrix A. Alright, so we're going to go second function, x to the -1 takes you to the matrix list. You can name the matrix whatever name you want, okay? A, B, C, whatever. I'm going to use A. So since 1 is highlighted, I press enter. That is going to store this matrix in A. I'll press enter again to confirm the entry. And you see how it creates a matrix for me? It looks just like this. -2, 3, 8, 3, -1, -5. This is matrix A. You're going to verify that that's the case. We're going to call matrix A and press enter and see what we get, alright? So we go second function, x to the -1 takes you to the matrix list. Press enter. It calls up the matrix and then press enter again. And then you see we have the matrix right there, alright? So now what we're going to do is we're going to carry out this RREF command on matrix A. There are 2 ways to find this operator. You can go to catalog and find it, or you can go to the math menu of the matrix mode. Alright, so I'm going to go onto the matrix mode, second function, x to the -1. You have names, math, and edit. Okay, edit allows you to change specific elements in your matrix or alter the dimensions. But I just need the math part, alright? So I'll go to math. You see a whole bunch of cool operations you can carry out on the matrix. What I care about is RREF, reduced row echelon form. So I'm just going to scroll down, 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 down. Bam, there you go. Alright, so this RREF, I'm going to press enter. RREF of what? Matrix A, right? So we need to specify the name of the matrix here. So I'm going to go second function, x to the -1 again to find my matrix list and select the first one. Alright, the second function, x to the -1, you have your list here. For the first one, press enter. And then close that parenthesis, press enter. Bam. This is the reduced row echelon form. This matrix right here tells me the answer or the solution to this system of equation, okay? So let me write down what the reduced row echelon form is, and I'll tell you what the solution is. So the reduced row echelon form is 1, 0, 0, 1, and then you have -1 and 2. Okay? So separating it right here, you have a line. Guess what? This matrix tells me that if this is 1 along the diagonals with zeros on the wings, that tells me that this is my solution. Alright? Guess what? This is my x and this is my y. End of story. Alright? So the solution to this system is x equals -1 and y equals 2. That's the solution of this system of equations, because it tells you that if you have an x here, you just have -1. If you multiply, you have an x, you put an x here. Remember, x has come up front here, right? So you can put an x here. 0 kills up the y, huh? So 1x equals -1, that tells you x is 1. You can put a y here. 1y equals 2, that tells you y equals 2. So there goes your answer. Okay? Alright, now, note, there are 2 special cases, alright? Special cases that you have to note when doing this. If you have a matrix that looks like this, 1, 1, let's say 3, and then 0, 0, 0. This is an anomalous case, it's a special case. If any row consists entirely of 0 like this, then in that case you have infinitely many solutions. Okay, so in a case like this, you have infinitely many solutions. All right, that's what this is saying. All right, because you can have an x right here, and you can have a y right here, And then think about two numbers that you can add to get 3. All right, you can find an infinite number of combinations to satisfy this equation x plus y equals 3. This could be 1 and 2, this could be 2 and 1, this could be 10 and -7, this could be -7 and 10. It goes on and on and on forever. So whenever you have zeros on any entire row, that's infinitely many, okay? Another special case to consider is if you do this system I'm showing you a calculator and you end up with an answer that looks like this. 1, 0, oh boy, 1, 0, have trouble drawing my lines. 1, 0, 2, and let's see, 0, 0, 1. If you have any case like this where you have a number, you just have a number on the rightmost column and you have zeros here, this means there is no solution. Okay? No solution. Okay? Because if you look at this, what on earth is this telling you? It's telling you that there is no x in there and there's no y. The x and y is both zeros and you're getting 1 as an answer. Does that make any sense? Absolutely not. Okay? So if you have not, just one number on the leftmost side and these two are both zeros, then that's no solution. Okay? But then you have an entire row consisting of zeros, that's infinitely many solutions. Alright? Okay, so let's try another example. I'm going to step this up a little bit because this works for any square matrix. I mean, any system of equations. So let's step it up to a 3 by 3. What if I had, I was asked to solve the system. X plus 2y minus z equals 2. This is like a typical algebra 2 problem or pre-calc. And then 2x plus 2y plus 2z equals 12. And x minus y plus 2z equals 5. Alright, so I want to solve this system. You know, if you've done this before, it's just a long process solving this manually. You know, you eliminate the variable by picking any 2, and then pick another 2 and eliminate another variable, and then you have a new system, and then you solve it. But I want to show you how to do this using this trick I just showed you, okay? So what you want to do is transform this into an augmented matrix. To make this into an augmented matrix, I will simply extract coefficients, alright? There are no coefficients here, so I'm going to put a 1. So I'm going to take out that 1, take out this 2. There's no number here, so I'm going to put out a 1. I'm going to take out -1. And then this 2, that's going to be my first row. And then this 2, this 2, this 2, and then this 12 is going to be my second row. There's no number here, so I'm going to put a 1, 1. And there's no number here, put a 1, -1. Positive 2 and 5, that will be my third row. Okay, so we're going to have a 3 by 4 matrix. Alright, so let me show you what the augmented matrix looks like. So the augmented matrix is going to be 1, 2, -1, 2 for the first row, 2, 2, 2, 12. On the second row, 1, -1, 2, 5 on the third row. So you have a 3 by 4 matrix. Alright? Alright, so I'm going to store this in matrix B, and I'm going to carry out my operation reduce row echelon form on matrix B. And if I have 1 along the diagonals of this matrix, this piece of matrix right here, and zeros along the wings, then and everything else is zeros, then that will be my answer. Alright? Hopefully we don't have any anomaly here. So let's go ahead and do it. Alright, I'm going to enter this matrix row by row as I did before. Open the entire matrix. We're going to do row 1, 1, comma 2, comma -1, comma 2. Close the first row. Open the second row, 2, comma 2, comma 2, well, a lot of 2's, comma 12. Close the second row, and open the third row, 1, comma -1, comma 2, comma 5. Close the third row, and don't forget to close the entire matrix. Okay, so I have the matrix entered in rows. Now I'm going to store it. Press store right here. Store it in matrix B. To access your matrix list, you just go second function x to the -1. Scroll down to 2, press enter, enter. Alright? Just to make sure that this is actually stored in matrix B, let's call up matrix B. Second function x to the -1. Scroll down to 2, I hit 2, enter. Calls out matrix B. Let's see what the contents are by pressing enter. So we have 1, 2, -1, 2, good. 2, 2, 2, 12, good. 1, -1, 2, 5, excellent. So what we're going to do now is we're going to carry out the reduced rational form. If we have the identity matrix here, that will be perfect. Basically, you just have ones along the diagonal and everything else is a 0. Alright, so let's see if that works. So to call up the RREF for reduced rational form command, we're going to go second function x to the -1. This is a list. I need the math. So scroll to the right, and then you have all these cool functions. Just go down, 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 down. There you go. RREF, reduce rational form. Enter. And then what are we taking the reduced rational form of? Matrix B, right? So let's call up matrix B. Second function x to the -1. Scroll down to 2. Close that. Enter. Oh, this looks beautiful. Notice you just have ones along the diagonal right here, and everything else is a 0. That means you have solutions. Okay, if I have like zeros down here, that means infinitely many, or if I had zeros and a 1 and a number here, that means no solution. Okay, all right. So let's write down our reduced rational form matrix, and we're going to extract the solutions from there. Okay, so in reduced rational form of B, reduced rational form of a matrix B is basically 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, 3, like that. Okay? Alright, let me fix that. Sorry about that. Uh-oh. Alright, now the situation here is you just need to know, there's just some names you need to know. When you take linear algebra or when you get to pre-calc, you learn more about all this cool stuff. So this piece right here is, it could be referred to as a coefficient matrix, and then this can be called a constant matrix, okay? So what is this telling me? It tells me that x is 1, y is 2, and z is 3. Okay, hope that makes sense, because here we have x and everything else is zeros, which means 0y, 0z. We both get cancelled out. So 1x is equal to 1. And this is y. Everything else is 0, which tells you 1y equals 2, which means y equals 2. And then this is z. Everything else is 0, 1z equals 3, which means z is equal to 3. So there goes the answer to your system of equations. Okay? Down. So thanks so much for watching this presentation. Please feel free to subscribe to my channels for more cool tricks on what you can do with your TI-83 or 89 calculators. Also, you can request videos if you have any questions on how to use a calculator. Just put it in the comment section and I'll try to help you out. More videos can be found on mathgoodstuff.com. Thanks again and have a wonderful day.